We're recording. All right, welcome everybody to Dallas Personal Robotics Group Builders Night Out. Tonight's February the 16th, and we have Freeze-ageddon going on in Dallas, and probably won't see many members because they're probably missing power and or water. But we're going to just muscle on through what we normally do here tonight. And we'll go around the table and see what people have to oh, I didn't do the title screen. Oh, well, after all that. We'll see what, I could see it, but you guys couldn't. So that's just how it is. So we'll just go around the table and see what people have been up to and carry on like we normally do. So with that, if I understand it so that, Doug, you've got something to talk about. Lead the way. Okay, well, I've been involved in a couple of projects this week. One is I've hooked up my Raspberry Pi to these RFID readers. I've got two of them in there. That's why it looks that way. I was checking to see if the one Pi could handle multiple readers, and it can. We're trying to come up with something for work with these. So you take these little dongles here, you touch them up to there, and you get to read. It's sort of like door openers if you've had that where you work. And so that's been an interesting thing. I broke it because I accidentally rewired something wrong, and I thought, oh my God, I can't get this to work. And then I got it wired back up, I traced it down, and found my wiring difficulty, got it working again. So that was cool. And the other thing I had to talk about is, let me present now real quick. I sent this document to the mail list, which was my first stab at command syntax for remote robot commands, what they send, what they ask for. So if you're in that mailing group, you will have seen that in the last day or so. And last thing is Murray's not here, but thanks, Murray. I was looking at your code and it had really good examples of Python classes. Since I'm a Python neophyte, I'm trying to start writing some classes. So good examples, kudos. We'll tell you how we liked it when you get here. That's about it for me. Unless somebody's got some questions about that.
Is that more Python, kind of a combination of C and Python, or classes a traditional part of Python?
Python is an object-oriented language, so I just need to learn the syntax. Yeah. I've only programmed in Python for maybe 6 hours total, so I'm trying to learn its syntax.
Yeah, it's a part of the language, and I'm new to it too. But it's not as strict about certain things. Like you can't have completely private class members. Only by convention, can you say, well, everything that starts with an underscore, consider that a private function or member. Everything else is public. So it's not as by the book as C++ and Java.
I'm trying to write some classes right now to wrap the SQL Server calls like I do in my .NET code. And so that's where I'm starting with the Python stuff, getting that ready.
Question about your card reader thing. I actually used to work in physical access control and in making those control panels. What comes out of the reader that you're using? Like, it's just like a standard UART, or is it SPI, I2C, or something else, or is it Regent?
Well, this is a RC522 reader, and it sends out through the SPI, which is serial bus, and it'll send a string. Okay. And you can write the string into it, and then you can read the string out of it. It's similar to a magnetic thing. You encode it in there, and then it is not magnetic, so you can't erase it. But and you can erase it with the proper writer tool, but it's not like sticking it next to a magnet will wipe it out. And people use them for door cards and access cards and things like that. What are you planning to use it for, Doug? Well, where I'm working, they want to use it to identify that somebody has a device in their hand, so that's going to have an RFID card on it.
So they prove, oh, I've got this device, you stick it up to the reader, and that proves you had the device at that location.
More like asset tracking.
Right, right. The person I work for, I don't want to say a lot in a public place, but he's pretty controlling. He wants to make sure people have their pagers and things on them when they show up for work, so they have to scan them in when they get there to prove they had it.
You know,
And that's good on that.
it's a common use case, right? Night watchman, did you go visit this place or that part of the building? I mean, it's a really common thing. So, or I think nurses and medications. I think there's a lot of similar applications as that.
Right. There's a lot of applications for RFID readers. I mean, that's what toll tags are.
Right.
But I'm using one that you have to be really close to.
Yeah, there's so many of them are near field. They're called NFC for a reason.
Mm-hmm.
All right. Well, cool. Good update then. So who else has something they'd like to share tonight? Oh, we got two hands. Chris was first.
All right. So because Doug mentioned the document, so I guess a couple comments on the telepresence robot. So one thing I did is I hooked up the Raspberry Pi camera to my Romy platform. You can see the ribbon cable. You know, it's kind of works out luckily in terms of where all the ribbon cable needs to go. You can see the Raspberry Pi is upside down in the Romy platform, but it all works out. You know, make a couple cuts in the Romy platform, and you know, so it's just sitting sort of halfway inside this upper deck here, inside a cut. So nothing fancy here. So I did that so that I can, you know, tinker around with some video streaming, you know, which many years ago I did that on the Raspberry Pi, and I tried, you know, as best as I could to get some low latency video streaming going. And so I dug up some of my old notes and tried some of those things, and then I tried a few other things. So I tried two approaches and see kind of mainly from the perspective of what's kind of the performance I can get. You know, the question I'm trying to answer is it feasible to do interactive real-time control of the robot, right? Or are the latencies so much that it's just, you know, not going to work? That is the question I'm trying to answer. And, you know, we know there's a lot of different ways to go about it. So the first way I tried is just kind of really no frills, you know, really not using any particular framework, but just basically an SSH tunnel to connect my Raspberry Pi to the internet. So I don't know. I mean, if for those of you who haven't done that before, it's kind of a useful sort of thing to do sometimes. Let me just illustrate that real briefly. If I share my other screen. So ignore the left thing here for the moment. So what I've done on the Raspberry Pi, if you don't mind me scrolling up here for a second. You know, obviously all of you are familiar with SSH, but I don't know if you've done SSH port forwarding or tunneling, but really all I'm doing is here, this is on my Pi, I'm SSHing into, you can see the complete command line here, I think. Apologies for the scrolling again. I'm just SSHing into my Amazon Elastic Compute Cloud instance, and one of the real cheaper ones, a penny an hour or something, or half a penny an hour. So I'm SSHing into that VM, okay? But the key here is as I'm doing that, I'm basically telling, sorry, here's the correct line. I'm basically telling SSH, oh, by the way, you know, anytime someone connects to that VM on port 5001, redirect that to my Raspberry Pi on port 5001. And anytime someone connects to my Amazon VM on port 5000, send all that over to the Pi on port 5000. Right, so this, again, some of you may know this, some of you may not, but this is just standard SSH tunneling, where you can basically think of it as a very primitive VPN, is what this is, right? Very primitive VPN, but the end result is the moment someone connects to my Amazon machine on port 5001, that actually ends up getting sort of forwarded or redirected or tunneled, if you may, to my Raspberry Pi. Okay, so that's how I, can get my Pi onto the internet without opening a hole in my firewall at home, right? Obviously, you could do some port forwarding. You could configure your home router so that it accepts incoming connections, but most of us don't want to do that. So this way I'm connecting out from the Raspberry Pi into somewhere else, right? Outgoing connections are always allowed, and the same way I'm using the Amazon EC2 instance basically to create a tunnel, right? And by doing that, right, what that allows me to do now is, and that's what I had this window up for. So this is just a standard Romy control panel, right? So no, I didn't do anything here. But as you can see here, I'm not connecting to my Raspberry Pi. I'm connecting, to some address out there in the internet. And by the way, you guys can connect to it too right now, except this isn't really designed for multi-user. So, a couple of weird things happen, mainly because of how the Pi talks to the Romy hardware. But basically, I could connect, if I just swap this out for 192.168.2.1.1.4, I get the same thing, but now it's obviously happening locally, right, on my local Wi-Fi network. But this is the exact same, and I don't actually, maybe I can illustrate that. So if I hit the LED button here,
It's across your local network.
This is across my local network. But you see that little green LED coming on?
Yep.
Oh, actually, yeah. So you can probably, if you look at my video and at the presentation at the same time, or I hit the play button, it makes a little beep. So this is my local network. Obviously, nothing unusual happening here. But let me go back. Doing that over, this is now, again, look at the IP address. Okay. I'm now going into I should say, I'm going through my Amazon VM back into my Raspberry Pi. So again, I'm going out from here to Amazon, which turns it around and goes back into the Raspberry Pi. So I'm going to hit the play button, and I'll illustrate that in a second how little delay there is, because I've measured it. And the bottom line is, it's actually pretty damn responsive. And I don't know if you can see the screen recording that I did. Can you see that?
It's pretty small, but we can see your OBS studio.
Yeah, so ignore the bottom right. Look towards the upper left, right? This is a recording of that control panel on the left. Okay. You see that recording?
Yeah.
And then on the right, you can see the camera stream. Again, this is just a recorded video, and I'm going to single step through in a second, and I'll show you how to get the video up. But this is the video and the control panel. And watch when I go through frame by frame. I go to the next frame, you see the motors here. It's going to say, let's see, where am I here in this video? Step. Why is it not playing? Give me 1 second here. Something odd going on. I go back a little. Sorry, I'm trying to find the right.
Clearly moving it around.
Yeah, now it's I don't know, it's supposed to be paused right now. It's not letting me pause it for some odd reason. Because I wanted to single step through, and I don't know why it's not letting me do it now in this presentation mode. But what I wanted to illustrate, because when I single step through, to measure the time from when I touch this touchpad to when there is change in the video, movement in the video, right? That amounts to about 150 milliseconds. Okay,
right.
Which is actually pretty damn small of a delay. And so
and that's round trip, right? That's round trip from your browser
that's
to the
round trip,
EC2
right? I'm
and
going
back
out, it's
to the.
coming back in.
Yep.
And the hard part is the video. Right. And again, I'm doing this in a manner there's really no security in the way. There's really not a lot of layers involved, and I'll show how to do the video in a second. But the bottom line is, right, with that sort of small delay, I'm able to, and I usually use the control panel. I usually pull that up on my cell phone, also on Wi-Fi, and then I look at the video. I'm able to drive it around basically interactively, right? That's what I wanted to see. Can I do that interactively with that delay on the order of 0.2 seconds or usually less? Okay. The answer is yes. Yes, it's doable. I mean, it's a noticeable delay. Okay. Once you get, I guess, beyond 0.1 seconds, you really start to notice it. I mean, when I'm on my local Wi-Fi, right, with this control panel, and Ray, you have a Romy, and so you probably have used this control panel before because it just comes ready to use with the Romy platform. I mean, it's pretty snappy, right? You touch on this little joystick area where it says motors, and the Romy platform. I mean, it responds instantaneously when it's all local. So going sort of through the internet here, it's that 0.15, 0.2 second delay in the video, and the control signal, right? It is very noticeable, but still quite controllable interactively. Okay, so for me at least, I think it's probably at the threshold of what's doable. I have a feeling once you get to 0.3 seconds, it wouldn't be fun anymore. The way the video is done. All right, so I mean the web interface, like I said, it's all happening through this port forwarding. I'm connecting to port 5000, but it winds up, on my Raspberry Pi port 5000. Now the video is done in a similar fashion. Like I said, I'm also doing the same thing with port 5001. If you connect to my Amazon machine at port 5001, you'll get the video. So what I'm doing here, if you can see this, I'm just using Raspberry Vid, right? The command line utility for taking videos from the Raspberry Pi camera. Some of you have probably used that. What I'm doing here, the important part is that last part here. I'm basically saying, well, listen on port 5001. And whoever connects to that port, you just send a video to that port. Okay. So that's a built-in feature in Raspberry Vid. There's other ways you can do it. Some of you may have heard of the Netcat utility, or NC. You can pipe it through that and get a similar effect. But this Raspberry Vid utility has this couple options built in. You can listen on a TCP port, or you can connect to another end. That's the listening side, right? So either way, the way I've done it, I'm listening on the Raspberry Pi. And so when I hit enter here, right, so it's sitting there now saying waiting for a connection, okay, on port 5001 on my Pi. So when you now connect to my Amazon VM on port 5001, and I don't know why that just stopped just now, and you connect to the Amazon machine at 5001, you'd end up establishing a connection with this. So let me illustrate that. Get this going again. It shouldn't have.
It might have been me, Chris. I tried to hit it and got no response. I'm on
all
your
right.
control page, by the way.
You have the control page?
I do.
Okay, let me close mine. You just beeped. You just did the play.
I
There you
played you
go.
again. Okay.
There you go. So the video, the trick to get low latency video, and again, I've done hours of Googling a couple of years ago and again this week, and the lowest lowest latency method I've been able to find is to use MPlayer, which is a media player application. And I'm running it on Windows here, but it's on Linux as well. But the trick here with this media player application, because I'm doing this over TCP, which is not ideal, but but getting anything else going in the manner I'm doing this gets a little more convoluted. So I'm just using straight TCP, which obviously can have intermittent congestion issues. And then on the playing side, you would suddenly have a 1 second lag turning into a 2 second lag, turning into a 3 second lag, and never able to catch up, right? Sort of to deal with that, the trick that I found on the internet is to tell this media player to, well, first of all, whenever possible, throw frames away so to catch up. Don't do any caching, right? We don't want buffering, minimum buffering. That's kind of what gets in the way of real-time video. But then the real key is you tell the media player, try to play at 300 frames per second, or 180, or whatever, some large number. Because what will happen is, and obviously it can only play as fast as it's getting the frames, right? And I send it 30 frames a second, but I'm telling it to try to play at 300. So what will happen is, if there's intermittent congestion somewhere, for a brief period of time, it won't get any frames, right? And all of a sudden, it'll get like a burst of frames. But because I'm telling it to play at 300 FPS, it's going to plow through that burst of frames instantaneously, right? It's not going to try to faithfully play a frame every 33 milliseconds, because if it did that, it would never be able to catch up again with the real-time source, because I'm telling it to play frames much faster than actually is possible. That's how it's able to compensate for intermittent congestion and catch up again to real time. So that's again, and then I'm telling it, all right, just go to connect to my Amazon VM here. And again, if one of you has MPlayer installed, you'll be able to run this exact same command, just only one person at a time. So boom, video pops up. And obviously you won't be able to tell much about, and I don't know if you can see the video because the way,
Oh yeah,
Yeah.
it's working
well,
well.
because sometimes the way video gets rendered, right, it goes directly to the screen. So you can't get a sense probably for the lag, but again, this is with the exception of occasional intermittent issues, it's pretty damn low in lag. I mean, I'm moving my platform around, it's updating instantaneously, right? So this is, again, like I said, I mean, from what I've measured, it was very, 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 very less. So again, I'm very happy with those results, except the way all this is working, it's not exactly sort of production, right? This is really just connecting a raw data pipe with another raw data pipe through the Amazon cloud machine, really nothing getting in the way except for my local Wi-Fi and in very little buffering in the middle. And so that's why this actually works reasonably well. But I guess it tells me at least what's theoretically possible, right?
Proof of
It
concept.
should theoretically be possible to get something going that has 200 milliseconds or less of a delay and do interactive real-time control.
Well,
Before I talk about the other thing I tried, which was what the thing that Donna had suggested from that Instructable or Hackster thing with the Kinesis video. Any questions about this particular setup that I can answer?
Chris, this is Donna. Okay, so that's first of all impressive work and impressive demo that you put together. Now that video capture that we were seeing live, now that was not displayed in a web browser, was it?
That's correct. So again, to get that low latency, like I said, the one thing that I've found to deliver the lowest possible latency is to connect that media player, MPlayer, it's a very popular media player, to connect that directly basically with the video source, which is the Raspberry Pi camera, and do it over the network in a somewhat convoluted fashion here, going to the Amazon cloud. But on the local network, instead of having an IP address like that here, right, I would go directly to my Pi on my 192 address, and this media player application is just very good at at rendering the video at very low latency, right? Because you can tell it, again, don't buffer, throw frames away, play everything as fast as you can. And so that's how you get real minimum latency. But like I said, this is not particularly useful, I think, because you need like a standalone application to get the video. We would want the video inside a web browser for sure. And there are a dozen different ways to get that done. I don't know yet what the fastest way, what the lowest latency way is to get that done in a web browser.
Okay, good. Thanks.
Because I mean, that's right now I'm just sending literally the raw video, right? As it comes out of the Raspberry vid application, it just spits out raw H.264 encoded video, not even sort of in any particular transport format. It's very low level, but MPlayer is able to figure it out. You know, you have to tell it, hey, you're getting raw H.264 and so on. You tell it that, but there's really nothing getting in the way that would add more latency, right? This is not getting encapsulated and then, you know, goes through other layers of software. That's how the latency is so low. I mean, that's part of the reason, I think. But certainly, you know, we would want it inside a web browser. And I know it's doable. There's again too many ways to do this. And some of the examples that you find out there, they don't always work right out of the box. So
That's a lot of progress, Chris.
yeah, so
pretty
this
good.
again, this is a while back. And some of this particular way of doing it, I found probably 5 years ago when I was doing a little bit of video on the Pi. I was sending it to a PC and had OpenCV going on the PC for image processing on the PC. So I was looking at that a while ago. You know, for doing it on a local network, I think this is probably the best you can do. I mean, you don't have to use this MPlayer application. I mean, you can have code in C or C++ with the right library that basically does the same thing. And, you know, you take in the video on the PC and then you do with it whatever you want. But again, so this is not sort of what we want, but again, it shows what should be possible, right? I mean, it should be doable. We just need to find something that doesn't add a lot of layers. Now, the other thing I tried, and I think that email came from you, Donna, with this example, using some of the Amazon Cloud features, because I already had an account that said I'm going to try that. So I did try that, and I don't think I have anything to demo here other than sort of the takeaway there is so that I did part 1 of the demo. Part 2 would actually deliver the video then into a browser. So I haven't gotten that far yet, but in part 1, you can look at the video coming from your robot. You can look at it inside the Amazon sort of management console. So you're in your account, you're sort of in your management console there, and you can look at the video. And I don't know if I have that up here. I don't have it running, that's for sure. But just to give you a sense of what it looks like, the takeaway kind of for me was the delay in the video. Okay, so I followed the example and it all worked as advertised, and there's a lot more going on than I understand. I mean, I've used, you know, a fraction of a % of the features that the Amazon Cloud services have. But, you know, you get this media playback in here in your management console. And I don't have the application running now on the Romy, but the lag, right, the delay in the video comes close to 1 second. So right away, that kind of turned me off a little bit, at least for what I was looking for is, you know, close to real-time control. And with this setup, at least out of the box with whatever choice of parameters that might play a role here behind the scenes, it's delivering the video, you know, with a, you know, almost a second of delay. So that gets into a realm where you can't really interactively, you know, control the robot anymore. right? At least not the way I was envisioning I would be able to control the robot. So that's kind of the takeaway there. Now there are, I'm sure, parameters involved here to tweak it, and I don't understand all of them. So I may look at this a little bit more. But just out of the box, it's just there seem to be too many layers in the way here to
But
deliver
Chris,
real video.
isn't Amazon also set up in the way that if I mean it's one thing to send commands SSH routing tunneling through EC2, but isn't it so that Amazon would charge for bandwidth so that if we were to try and run video streams that we could incur costs pretty quickly?
So the short answer is yes. So some of this would cost money, but it, let's see. And I looked at the pricing once for the video streams. It's very little. I mean, you're talking pennies per gigabyte.
Huh.
So
Okay.
it's in general, I found that the Amazon services are quite affordable. I'm sure it's the same with the Google and in the Azure. They're all competing, right? I mean, it's my virtual machine that I'm running, is costing me, um, fraction of a penny per hour, um, and so it's again in general their services are pretty cheap. But you're right. I mean, you're right. It's not completely free, right? I mean, I'm already paying for my internet, right? With my cable TV and internet. So this is obviously a charge on top of that. And I know I'm paying per video stream, I'm paying 3 cents a month just for the video stream itself to exist. Yeah, so I don't know how much the data itself costs at this point. It's not even registering yet. I haven't sent much data, but just the VM is, for me at least, what I'm doing with the Amazon stuff. Just the VM itself costing me usually, couple bucks a month, and out of that, most of it is actually the storage, which I usually never delete. My 30 gigs of storage costing me $3 a month, and then as needed, I fire up the virtual machine. These days I've left it running for a couple of days, but usually I fire up the virtual machine and shut it down when I don't need it anymore. So I don't pay for that for the whole month when I'm not doing anything. But yeah, so yes, you're right. Some of this costs money. Some of these things, the example that was provided there was specifically done in a serverless fashion. So you actually don't need to dedicate a whole server to it. So that was the one special thing about that example. It's set up to be operating in a serverless fashion, but still I think there are some charges, even though they do advertise in the example actually that it all
Free tier.
works with just the free tier, but I'm not sure that's true. So yes, so there are some charges, but bottom line is that there would be minimal in my opinion. Now, so the video had a big delay. Part of the demo also was, it gives you an API, right? A web service that you can invoke, right? That sends a command to your robot. So I tried that as well. There was also noticeable delay in that. Now I don't know if that was due because I just did just one-shot commands. There is obviously some connection establishment that takes time. If that was done in a manner where the connection is established only once, and then you just issue, these API calls with an existing connection, I would imagine would be faster. But at least the way I was doing it as per the demo, there was a noticeable lag also, again, in the command, me, hitting enter on the command and something coming out the other end on my Romy. So that was also well noticeable. I didn't time it, but the bottom line is it was quite
You could feel it.
quite noticeable.
Well,
So
it sounds like, Chris, is my perception right that when you did your SSH trick, in effect, it kind of looks like a socket, straight from your browser through the EC2 straight to the Romy. Kind of looks like that.
That is correct. I mean, it's really two sockets though, right? Because
Yeah, yeah,
there's one
right.
connection to the EC2, and then SSH is on the EC2 VM. It's the SSH server that's sitting there listening on those ports, and then connecting it through the SSH tunnel, right? Because I have to have this SSH connection going, and I don't remember where that
But
went now.
once it's open, it likens to me like a socket, except that it has this extra gateway thing in the middle, a bridge.
Correct, correct.
Versus the serverless thing, as I read through it, it looked like it was wasn't it using HTTP puts and gets, or
Yeah, for the commands, I think there's some MQTT involved from what
maybe
I've
that
read, and
too?
honestly, I
Yeah.
haven't quite read how it's implemented behind the scenes. The video, there is supposedly some WebRTC involved.
There's that. There's user authentication, and I mean all those layers that you talked about cutting out for your SSH method. It sounds like that example has every one of them in place.
I mean, one takeaway for sure with the Amazon demo is not my stuff, but the one that's using the services is, again, there are APIs and services out there, probably from all the major cloud providers, for this kind of stuff. Right? Let me see if I can I fired up that application now that runs on the Pi. Again, it's just a Python application that um, kicks things off. And if I now click the play button here, in theory, that should establish a connection with the camera. There you go. Now, again, you may not be able to tell what the actually, yeah, so it's maybe a tiny bit faster than last time I ran this, but I mean, again, I'm moving the Romy.
I can see a delay between what you're doing and then what is showing up there.
I mean, it's probably 0.8 seconds. That's my non-scientific measurement here. Okay, so it's quite noticeable. And then again, there's a way to initiate an API call, which I forgot how to do now. I don't have the command ready. And again, it shows up maybe half a second later on the Romy.
Well, as long as you drive slow, you can do it. It'd just be aggravating.
Yeah, I mean, for interactive real-time control, unless there are parameters that can be tuned to really sort of, get this delay down, yeah,
You're not going to be racing
it'd be very
somebody.
difficult.
You could
Have you
drive
tried,
across the room.
sending it by UTC?
Or MQTT. We're not sure, Pat. We'd have to look at the. I put the links for the examples in here that Chris is working from, and I think you said, Chris, this is from the part one.
This is part one, and so
yeah.
part two, basically then uses some other Amazon service to help present a little web page, much like that Romy control panel that I've shown, right? But a web page with a video on it as well. So I don't know if the delay is going to get even worse with that setup or not, but I'll probably give that a try because the example seems to be going pretty smooth and everything works as advertised. So it's just a matter of typing in the commands and waiting for stuff to get installed, and then it all worked pretty much as written in the example.
Sorry, Chris, I meant to say UDP, not UTC. UTC is from work on some time I've been sharing between my PLCs.
Yeah, so let me think. Is this behind the scenes? So this Amazon stuff, well, let me check actually. So I'm not 100% sure what that is using behind the scenes.
Because you were setting up a TCP link to it.
I was, so my stuff, my hack was TCP, and that's because you can't tunnel UDP over SSH.
Okay.
At least not directly, and so that's why TCP is more natural for that hack, and although it's not the most ideal for video, but the Amazon IoT stuff. So let me see what's going on here. What's established here? Why do I not? Oh, I just did the listening one. Sorry. I need to do netstat minus a. I don't want the address. I want the address. So, there's no. This is UDP local. This is time service. Something 123 or my Samba. So it would appear, because just looking at the UDP stuff here, there's no UDP connection established other than something else I have locally going on. So it would seem, yeah, okay. So there's some TCP. Okay, yeah, 443. So between my Pi and, okay, these two seem to be the one, the outgoing connection from my Pi to HTTPS somewhere in Amazon land, right? So no UDP involved here, no real time, video transport protocols taken advantage of here either. It's all TCP wrapped into a bunch of other stuff, and all of that, probably adds latency.
That's what I was thinking. The TCP is probably adding a little bit of latency in there.
But again, as I demonstrated, it doesn't have to, right? If you go bare bones,
Yeah,
brute force, and do it in such a way that you mitigate the occasional congestion by just playing faster than real time or attempting to, it does pretty well in TCP. Again, you can't go crazy, right? First of all, I only have a 6 megabit per second outbound connection, so I can't do more than that. But I found that as long as definitely with 2 megabits, I don't run into any congestion issues. As you go up, right, you're more likely to get into situations where it stutters a little bit, but so you just want to keep it modest.
So Chris, how long did it take you to get to that part one?
That part one, actually, the longest, what took the longest is because he insisted on doing an update on my Pi, which ended up having to pull down a lot of updates and install them. That took the longest. Everything else, the instruction tell you, go run this command, go download this install script, run the install script, which really does most of the work. So the rest was actually pretty straightforward. I mean, it probably did take me altogether 2 hours to get part one done.
It's very okay. And you have
But
some. You clearly have
everything
some
worked as
experience.
advertised. So if you follow the steps of part one, again, if you have an Amazon account, AWS account.
Well, that's another thing, right? Because you clearly have some kind of Amazon under your belt. I have a little bit, but I bet many of the DPRG people don't. But
I know how to spell.
Oh.
Yeah. So that would add another, I would guess, hour or two just to learn where the
if you don't have an account, and I don't remember. I mean, obviously, if you have Amazon Prime, I'm using the same login there and there, so it's all connected, right? But again, frankly, the fact that I used the compute cloud for a long time now, there are so many services in there, right? None of this that I had to do for this example was familiar to me, right? Just look at how many services they have, right?
Oh, it's crazy.
It's nuts, right? The only thing I'm familiar with is this one right here, EC2. That's the only thing I know, right? Everything else is pretty foreign to me. And so, but again, you just follow the steps as laid out in the instructions, and they tell you where to go, and it was pretty easy to follow.
Oh, good. That's cool.
It's impressive.
But again, I think the main takeaway is, right, there are frameworks out there, APIs out there, IoT plumbing is out there. I'm not sure we have to reinvent the wheel ourselves. Obviously, if you buy the wheel, maybe it won't perform as well as you'd want it to. But when this is just one set of infrastructure here that does some of what I think we've been talking about. Be interesting to hear from Harold if he thinks, you know, Azure can do one better.
He's not here, but I can tell you after, because I've been in his life as Hackster Dallas chairperson or ambassador or whatever they call themselves. They've hosted many meetups, and most of them seem to be focused on Azure because they're Microsoft MVPs, he and Ron. And I've been to a few of those, and from my eyeball, I mean, the console and the web console looks a little different, but as you say, that whole long laundry list that no one will ever know all of in Azure, I mean, AWS, the same list or similar exists. It's just spelled differently. And I mean, they had a couple of IoT specific kind of frameworks that make it easy to tie devices into in a secure way, and they're made to pass data to and get data from, and they come in different classes of bandwidth and payload size and latency. So those, I would bet you that Harold could say it's at least on par with what Amazon has.
Yeah. And, you know, again, even within Amazon, and probably same for Azure, there's probably more than one way
Yeah.
of doing that sort of thing. And again, I don't know enough about all the services. And, you know, within this Kinesis video streams service, you know, again, oftentimes it's a matter how you configure things, right? So it'll take a little bit more Googling maybe to see what people are saying about what performance they experience and what they had to do to get the most out of that service, right? The lowest latency. I mean, I haven't even sort of Googled that and to see what other people are finding and saying of what, you know, issues they might be running into. So that'd be the next step, just to see what the chatter is about Kinesis video streams and latency.
That's pretty cool. That's a lot further than I was able to get. I was going to try and measure the
Well, I had the day off yesterday, so I had a little couple extra hours on my hands. So
nice. I was going to measure the latency just using, and I still do that. I think there's still value in measuring the latency for Google Meet or Zoom, because it seems to me that like the trick you have where you're dropping frames and then speeding up to catch up the buffers, I think that might work okay for video. But if you try and do audio is not going to survive those kinds of things. No way, right? So it seems to me that trick you've got might be good for a kind of a heads-up view, first-person view, but we're still going to, I think, need a parallel path for video interaction for human. I can't see running that through any kind of other EC2 or something.
Especially with the voice, you have a good point about the video, the sound versus video.
Does anybody know what the latency is with like Google Meet? I mean, has anybody measured that? I mean, I haven't Googled it, so I have no idea what range it's in.
I was going to measure it, but I get the impression that it's, well, as I look at myself here, because I have a screen off to the side, and when I talk, I mean, my lips are out of sync. It's a little bit like the Chinese or the Japanese sci-fi, right? Does that work? Yeah, here we go. You can measure it right now. Where's the glare? How do I get rid of the glare? Okay. All right. So now can we see me on both screens? No, we can't. Yeah. Hello. 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 Hello.
Too much glare.
It's like a second, right?
Related to when I watch the Channel 5 news here, they've got their remote newscasters and they'll say something to them and they'll sit there with a blank stare for about a second and a half and then they start responding. I think that's that same latency.
Yeah, it's going to be hard to get away from.
That started happening after I turned 50.
Puppy.
Yeah, I'd say my wife says that to me all the time, but okay. Well, which makes it to me all the more remarkable that we're able to have this conversation like we do without stomping over each other much more than we do. Because delays will cause that.
Well, the server in the middle is really managing all this stuff to make it good.
Yeah, and again, I did a ping, and I mentioned that last week, right? When I do a ping into the Amazon cloud, I mean, the round trip is usually no more than 30 milliseconds, right? So under the hoods, right? I mean, most of the time our connections are pretty snappy. A bit again, occasional. It's the occasional congestion that's, I think, the biggest challenge for all of this real-time video streaming, right? How to deal with that? Because 99% of the time you get lots of bandwidth, fairly low latency. Just intermittently you're gonna, you know,
A
have an
bursty
issue.
dropout.
Well, I'm just excited that it looks to me like the near real-time control is relatively doable.
Viable. Yeah.
So I can quit worrying about this polling command structure stuff. May not be needed.
Yeah. See, I've thought for a while. I'm willing to bet that if we use like the HTTP and the MQTT or whatever, these slower things to set up channels, but then if we use sockets or something, or like your SSH, but something like that, where it's just an open pipe, send a bit down the channel, it'll just get there. I'm willing to bet that that'll give us a pretty good mechanism if we use a hybrid of approaches, if that makes any sense. So anyhow, okay, cool. Well, thanks, Chris. That's awesome. So who else should we stay on this telebot for? Oh, Pat, I'm sorry, you were
Yeah,
just behind Chris, and you've been very
I've got
patient.
just
Jump in.
a little update from last time. So everybody knows what those are.
Oh yeah.
Remote. I've been doing some troubleshooting since I zapped my Pi a couple weeks ago, and that turns out to be my problem.
Oh no.
My little USB receiver.
Your Bluetooth, or it's not
Yeah.
even Bluetooth, is it?
It's Bluetooth or it's proprietary or whatever. I don't have to
Proprietary.
pair it,
Yeah.
and it makes it nice to use. But it's now hanging up the connection sporadically after 2 minutes, after half an hour. It's just, it disappears and I have to unplug the dongle, plug it back in, and off I go again. So back to waiting in the mail for something to come in. One of my questions was, is anybody using anything else besides these and the direct connection to Bluetooth? Is there another adapter you can get?
Yes. So I have it's a PS2, right?
Yeah.
Now I've tend to buy them from Lynx Motion.
Okay.
They're a little more expensive, but they seem to be a little more robustly made than the ones you can get cheap knockoffs off of Alibaba. But they come with a PS2 dongle, and it's like $25. You get the dongle, the interface card, and this guy. And I did have to spend some time, I found, to clean up the library that opened the common library that's available for this. But I've been very happy with the results once I got the library cleaned up.
How does it communicate from the dongle to the whatever you're using, a Pi or an Arduino?
It's a standard. It's just let me see. What do they call
Isn't
it?
that one Spy?
I believe it's I2C actually. It's I2C or Spy. It's one of those. Two.
Yeah, I think it's more like Spy than I2C, but whatever it is, it's definitely proprietary. I haven't been in that code for a year. But
okay, so it's something we could use fairly easy to port over to something else.
Oh,
if it's Spy, it would be easy enough.
PS2 does use Spy.
Yeah,
I just looked it up.
Yeah, you just, I mean, if you want to see what's involved, I can send you a link to the repo that I have for that, and you can see the sort of upgraded library to interface with that.
Okay.
I can dig that out.
Good. I'll check the chat for it.
Yeah.
And so that's what I've been working on, and watching videos of everybody sending their robots in the snow.
Where's your snowplow?
The snowplow. I have that one you sent me. And,
snowplow bot, but you need to make one now. You've got the base for it started.
Yeah, you know what? It's in a couple of years from now, I'm going to wake up to a plowed driveway every time it snows. So I like the option. They didn't go too far into depth, but using RTK GPS signals and doing a little bit of mapping to lay out the driveway. And I don't know, looks definitely interesting and a worthwhile project. So that's it for me. Short and sweet.
Cool. All right. Who else has something to share? Somebody has something.
Well, I
Well,
can show you that thing I was
Observation.
earlier.
Talk
Uh,
about contest. What if you had a contest for snowplow robots? You might have trouble finding snow, but the ability to push that stuff around could strain some of the motors. Could give you some things to work
It would
on.
need to be gas
There's no
powered.
shortage of snow.
We could go to Ontario in the winter.
Yeah. In 95, I grew up in Sault Ste. Marie. In 1995, that we had 20 and a half feet of snow fall for the winter. So it gives you an idea. There was nowhere to put it.
That's
And
a lot of plowing.
yeah. And then a typical winter will have anywhere from 6 to 8 feet of snow here. So it falls, it compacts, it melts a little, compacts some more. But yeah, there's usually no lack of it. The problem becomes when as it melts and it gets cold again, it turns to ice, or it really gets hard. And there's no plowing that unless you weigh 5,000 pounds.
And there's no salting it either, right? Because you're not going to empty the salt mines to melt your.
I usually use about 20, 30 pounds of salt on my back steps and walkway out to the driveway in the spring, in the fall, in the spring and the early winter, to keep from sliding all over any ice.
Each night or over the whole season?
Over the whole winter.
Yeah, that's not bad at all.
So that's usually it's a couple 5-gallon pails of salt. Basically, I use.
Huh.
Is this gonna affect the soil with salt in the soil?
Eventually it will.
I don't know. I'll be dead in 10 years, so what's it matter to me?
They've been dumping tons of it on the roads for years, and nobody said anything yet.
Yeah.
If you live near a body of water, you should care more. But
the plants I wouldn't worry about as much as the cars, because in the roads, because here in Pittsburgh, pothole central, right? The salt doesn't help, and then the cars just rust out.
So I don't know about you guys, but here we can't use weed killer anymore. They banned it. There's nothing that really works. So everybody come up with a homemade recipe for weed killer, and we've been using vinegar and salt is one of the things we use. Well, I could tell you this: I've dissolved 10 pounds of salt in a bunch of vinegar and put it on all the weeds that grow up in my gravel driveway, and they still keep coming.
They thrive, huh?
Oh yeah. I don't think the salt is doing anything to it. It turns brown, dies, and grows right back.
So I do have a new project I've started on.
What you got, Jesse?
I'll show you. I'll show my window here. I'm not sure. Not sure if I can. A window. A tab. Just a second. I don't think it shows up.
You have to click on present now, and then when it shows up, you have to actually click on the screen to share.
It's trying to do a Chrome tab, which is not what I want. So a window. No, it doesn't show up. I'll just share my entire screen. Okay. Is it up now?
Yes.
So what I'm doing here is just playing the snake game, but I've set up just a simple algorithm for it, and I'll slow it down so you can actually see it. And basically, this is like just an algorithm I designed. It's not the best algorithm in the world, but it works. And the idea is this will be my gym for testing a neural network. So I plan to try to create a neural network to solve this better than what this algorithm does. So the ultimate goal here is for my RC tanks and to create a opponent for that, an AI for that. But since I'm just getting started in this, I just wanted something easier to test. So this is what my start of that. So I have all the framework set up for it. And now what I can do is pause it and go up to the infinite speed. And now you'll see it runs a lot faster. And it even runs much faster yet if I just disable the display. So you see right now match 6, 7, 8. So now if I turn off draw, you see it goes way up. It's much faster. So it's just running through and just using my simple algorithm, which is just proof of concept for the framework. And so now I have to actually implement a real AI for learning for it.
What framework are you planning to use for the neural net, or are you going to do it just completely from scratch?
I'm looking at using libtorch, so PyTorch basically. But I'm a C++ guy, so I'll be using libtorch, and then I'm looking at different reinforcement networks right now. Or I might try to use the DeepMind, the environment for simulating Atari games, for being able to control Atari games. The Snake screen is 40 by 40, so it's similar to an Atari screen. So I might be able to just use the same code base and instead of sending an Atari game, send it the Snake. Or ironically, the tanks. And my tank game is really based off of the original Atari combat game. So I think I really like the idea of trying to almost emulate a Atari screen so that I could use the AI to get a solution for it. So it's kind of an interesting idea. But I wanted to have a gym environment, which was my own first, and so that's what I'm doing here with this snake. So.
And then, so I understand this is a learning exercise, right? So you said you're gonna then use a neural net on your actual robot, and so
Yeah.
how are you planning? What is the neural net going to do for you on the robot?
Well, that I can show you here with my game that I'm working on. This is my tank game as it currently stands. This is really going to be a fully functional game, so it has all kinds of network connectivity and controller setup and all that. And I have a PS4 controller as well and a wireless Logitech. So I've been trying with different controllers. But so here you would say computer and start. And so now the computer will play one player and I'll be the other player. And so I can now drive my tank around and try to shoot the opponent. So the idea is eventually to create an AI that can drive the opponent tank.
Oh, there's a laser beam coming out in front, some sort of laser pointer thing, and then you have a target.
That's your tracking, so I can turn it off if I want, but it just lets you know where your turret is currently aiming. But yeah, when you hit the fire button, it'll fire like a simulated laser, and you see there the opponent hit me. This is just a really simple algorithm I created, and it's good enough to give some people trouble, but so then I can fire, and you can see when you hit the other tank, then they get a red, and then when they get all red, then they're done. And this is identical to the actual tanks that I have. So I'm basically doing a simulation, but I'm calling it a game because I actually might release it independently as a game. And then when you hit your opponent, you have a shield for like half a second, so you can't get shot too much in a row. So it gives you a little safety period, so you can't be shot again. And then you can move your turret from left to right. In the standard mode, you can only move it 180 degrees because that's what the RC tanks can also do. But in the advanced mode, you can actually turn your turret 360 degrees, so you can actually have it facing backwards and drive. But the idea here is you have a blind spot behind you where you can't shoot. The idea is try to sneak up behind somebody and shoot, but the turret turns relatively slowly, but the tank itself turns much faster. So if you have somebody behind you, the idea would be to just turn around. But
So is the idea that two autonomous tanks will basically battle each other?
well, at first what I'll do is I'll just have like an opponent in the corner, and all it'll do is just sit there and wait for the enemy to show up, and then aim towards it and shoot. And I can create the code to do that relatively simple. So my first level of training could be put a tank in the corner, and the computer has to get within range and shoot it, and get out of range before the enemy can shoot it. But that's where I'll start. But then yeah, eventually the idea would be for it to play itself. But I don't know what kind of strategies will come from that and how well that'll work. So that's a lot of the experimentation will come in. So this board right now is 60. It's 6 feet by 4 feet, so it's 72 inches by 48. So I break it into one square grids. Now the tank doesn't have to be exactly in one square. It can be in between because I use floating point for those. But as far as the simulation goes, I really could put it in each individual square and not like have it do in between. So I could break it down to a arena of 64 by 48. I mean 72 by 48, or I could even potentially cut it down further. But that's my ultimate goal, and you can just see how far I've gotten on that because I even have like the controller set up going, so you can see what controllers connected and what buttons do which. So I'm really trying to make it a real game, but I really want to have a fully functional AI for it.
Do you have? You said you have those tank robots already.
Yeah, I can send you guys a link. I'll send you a link to a video of them running around.
Okay, so those are off the shelf, or you built them from scratch?
I built them from scratch. So they're based off the tank platform from Polu. I don't remember what it's Zumo, or whatever. I think it's Zumo. So I'm using a Zumo chassis and then a custom built PCB for it. I'll send you the link.
That's
Okay.
looking like good progress, Jesse.
Yeah, I'm off from work this week, so I got more time than normal.
Cool. Okay. Hey, maybe at this point I'll jump in for just a moment. It's not exactly robot related, but as some of you may know, I'm on travel here at my parents' house. So I drove up here at the start of January, and I've been trying to figure out when to get back to Dallas. And I just thought it'd be interesting if you ever have to do cross country drives in crazy weather like this. I found this app called Drive Weather, and what it'll let you do is put in a starting point and a destination point, and then you can say, well, if I leave at such and such a time, what's the weather? Like when I'm at Memphis and Nashville, that's not good. It's frozen. If I leave at 10 tonight or tomorrow night, there'll be frozen roads at that point in time in Nashville. So I better leave a little bit later. Okay, looks like Friday morning. The gray means overcast, and the blue is blue skies. So that's my departure time.
Of course, the weather forecasts are always right? It's an exact science. So.
They're always right. But there is something to be said about, like, if you just look at, and I've been watching it for the last few days, no matter where you put the slider, someplace along the route is going to be a mess, right? Until you get to Friday, and then it starts to clear up, and then it's just clear until you depart on, like, now Sunday. So it looks like there's a decent window in there where I have good odds. Anyhow, I thought for anybody that has to do this kind of thing, it was
What's the app called?
it's called Drive Weather.
Cool.
Nice
Drive
app.
Weather. Yep.
But yes, I would say I bet Saturday is the day when you will leave offhand.
Yep, we'll see. I'm aiming for Friday morning. If it's Saturday morning, one of those 2 days, I should be good. Both days.
Okay, I can share my video now. I'll show you the video.
Okay. It's looking cool.
So these are being driven by two teenagers, so they're actually much better at it than the general kids are. These are first robotics competitors, so I'm like, somebody who knows how to use a remote control, thank you. So it uses infrared and has 4 infrared sensors, one in each corner of the tank, so it can detect from 360 where the shot is coming from. It's using like a sharp protocol or something so that you can have more than 2 tanks and you would know which tank hit you, and you could have things such as team play, stuff like that. So and also if you see a reflection of your own firing, so it doesn't count that as being a hit. But the funny thing is, the whole reason the walls are black is because even without that, the infrared is strong enough for reflections to be seen. So I have to paint the boards black in order for the shots not to be seen. And also, for the same reason, the barrels had to be metal, because the infrared was actually transferring through the barrel. So even if you're alongside one another, it would still detect a hit. So I figured out the only way it was not intense enough was to make the barrel metal. Even I've really reduced the amount of LED power that I have, so I have a resistor in there to drop the power, the voltage the LED sees, and even still, these have a range of 30 feet, so they got plenty of room for infrared, like for sun interference and that. And I'm using maybe at 1/100th of the LED power, because it's a really powerful LED. And I got that one because it's a very narrow LED, so it's not like the normal ones on TV remotes where they have like a really wide beam. This has got a very narrow beam, but as a result, it's very strong. But it works.
Sounds like a fun game.
Yeah.
I noticed the sharp receivers, the receivers weren't kind of shielded in any way. So you don't, do you care which receiver you hit with your beam, or
No,
do you not care?
I don't care currently, and I just did that so I can get the most coverage to make sure one sees the hit. If you put it in the side of the tank, there's a chance that a hit that should be valid might not be seen if I shield them too much. So I did think about that, and maybe having different types of damage based off where you were hit, but I haven't really got to that level of finesse yet. I wrote the code before the Kansas City Maker Faire. I was literally working on it the night before the Maker Faire, and I haven't actually touched the code since, because it's actually worked really well. But it's got all kinds of diagnostics and calibration stuff in it too. But the basic functionality seems to work really well. I've got about 35 hours total runtime on the tank so far, and I've had no failures whatsoever. So I would say they're going pretty well. So I think I told you before I was working on this, and I'm trying to eventually decrease the price per tank to something reasonable, because with everything being hand built and using breakout boards for everything, it's too expensive right now. So the goal with the AI would be to have a real opponent for the real tank, and then I'd probably use cameras to track the motion of the tanks, like Open CV or something.
And then to kick it up a notch, put camera on the tank and do it remotely, so you just see what the tank sees.
Right. Well, I even thought about try to do tensor light and actually do the AI on the tank itself eventually, but that's a long ways down the road.
Multi-step project.
Yeah, yeah. As you would say, it's really it never ends.
Very cool. Good progress there. Okay. Well, we keep grabbing people online, so I see more from Dallas. Hopefully, the power has been good to you. If you're just joining now, who else has some cool stuff they'd like to share?
Well, I can show you the thing I found. We can throw stuff on top, but there's this Snap Rover, so I don't have the parts for it, but I actually have the base. So I'm reading up on it. But basically, on the back, it has a part where you would plug the wires in, and you can put for the motors. And then if you look online, you'll see. Well, actually, I can share probably that window. Let me share that window real fast. Window. There. So this I got a couple of years back and I haven't really played with it too much, and so I've misplaced the parts. But basically, what? Did this not work? Okay, tab. Here. Basically, you have the base and you have a thing on top that you snap different things on. But I was thinking of just getting rid of the top and plug directly in. So basically, let's go click along. So you see you have little parts that you snap, but the key is on the back end. They have a remote light thing. But right in here on the back end, there's basically where you can plug your wires to the motors for the base. So that's why I was saying about having a base and then put stuff on top. And I'm thinking Raspberry actually put on top of this. So that's where I'm at. I just now need to dig out my Raspberry amongst other things. So that's my thing I have done mostly this week.
John, did you buy that or 3D print it?
I actually got this way back, several years back over at Micro Center, a couple years back. And then I put it over to the side because I was busy working on some other project, basically another RC car outdoor thing, I think, that year. So, and just as I was surfing that web the other week, you saw one of those projects where they use this for the base with that pole thing. In fact, last week I think I showed you all that website on the instructables, and they had the base that this is the base that they use. So I'm thinking it may work well. So we'll see.
Cool.
In the meantime, I see Jack there. So hi, Jack. Speaking of people in Dallas area. So I don't know if you want to talk, Nez.
Oh, I unfortunately haven't gotten a lot done robotics wise. My printer actually jammed and I've been spending most of my time trying to fix that. I thought I'd do an easy way of just replacing the nozzle instead of actually trying to clean it out, and turned out to be the wrong size nozzle and ended up screwing up a bunch of internal parts.
So you haven't worked on your outdoor cooler thing?
Yeah, that I pretty much finished last summer, actually.
Okay.
So I'm actually looking for a new robot project to do. I was thinking, what do you guys think of a robot that plays the violin? I thought I'd try that.
I played the violin for 11 years, so I'd say good luck with that.
Yeah.
Yeah, I used to too, but I don't know. I thought that would
Well,
be
the only other musical instrument we tried was a xylophone, and we made the mistake of bringing that up with us to Tyler, and it played for hours.
Yes, I was going to say xylophone or piano.
Oh, yeah.
Might be easier.
But
the piano
but
might
Jack,
be
it is.
easier.
You want a new idea?
Yeah, probably.
You want a new idea? You can read an old book. There's a place in where is it? It's called House on the Rock, and I think it's Wisconsin.
Okay.
And in one of the rooms in that House on the Rock, in several of the rooms, they have these. I don't know, is it 20s or 30s or 40s era mechanical orchestras, and in those they have a number of stringed instruments where they were mechanical robots, but they were mechanical things playing stringed instruments.
Really?
Yeah. So that it's
Uh,
been done before, but you could do a cool
Uh-huh.
thing with Arduinos and servos and stuff. I'm sure.
Yeah.
That
What did you
that
say
place,
the name was?
House on the Rock, it's pretty amazing, and
Oh, okay.
it is up in Wisconsin.
Okay.
They have the world's biggest carousel in it.
Huh.
I like the theater organ too because it's fanciful. Apparently, the guy who did it, he had a habit of collecting things. So as you walk through his collection, it takes all day to walk through his house and his collection and his warehouses of collections. And he did this. What would he do, Jesse? He would take a whole bunch of antiques, and then he would go make like fake antiques, and he'd
Yeah.
mount them all in the same case. So you look at like these
Huh.
like muzzle loaded handheld guns.
Yeah,
It'd
guns
be
was the example. Yeah.
gun after gun after gun, and then right beside that there's like a rapid fire gun. It's like a Tommy gun in a handgun form, and then there's another one with like, and you'd have to scratch your head and think, okay, this one looks real, that one looks real, but no, it can't be real. And you just stand there staring at it, scratching your head, trying to figure out which one he's messing with you and which one's real.
Huh.
Anyhow, I enjoyed the place, and the mechanical orchestras. If you go there, then down the street, there's also Frank Lloyd Wright's Taliesin East.
Okay.
So the two architectural, really well-known icons there.
Huh.
You really have to spend all day there if you didn't go to the House on the Rock.
You do it. We did both in the same day, and it was too much. I'd say
Oh,
a
okay.
day for each.
Huh. I'm looking it up right now. Is it a bunch of humanoid-looking things?
No.
There's some of there might be some of that in there, but
Oh, okay.
I sent a link to the exhibition.
Oh, okay.
And the chat section.
Mhm.
So there's
He was talking about like the music of yesterday. Carl was talking about that. That's one of those sections.
Yeah, there's
then there's the organ room, and then there's the indoor carousel, which is there's so many things. It's really insane.
Huh.
Yeah, so here's one example where they had humanoids kind of playing. So this is one of the many rooms in this house.
Oh,
And
okay.
he has one like this where they're just, and they all play. I mean, you push the button and
Yeah.
they all play together.
Huh. That's cool.
Yeah, it's more than you can take in by. Well, anyhow,
Is it in the
you can
city?
tell Jesse and I enjoyed it.
Is it in the city?
No, it's not. It's kind of out in the country.
Oh, okay. If you're looking
Destination.
for people to go next, I could go and tell you what I've been.
Jump in,
sidetracked
Ray.
with.
Yeah.
Okay.
Something robotic because we keep distracting ourselves.
Something robotic. Okay.
Or I keep distracting us.
All right.
Also, I am curious. I was gonna get an SLA printer. I was curious if you guys have any advice on that.
Do you have a budget in mind?
I was thinking like $300 or something. I can go over that though.
There's
Why?
either the I'm a big fan of the Prushas, and those are of course more expensive.
Oh, okay.
They have the mini, which I believe is around 350, but there are plenty of printers in that price range.
Okay, and they're resin printers?
Yeah. Oh no, SLA. I thought you meant like.
Oh, right. Yeah. Yeah.
Have you looked at Micro Center? They had one for $200.
Oh,
It had
really?
3.5 by 5. I actually have it. I forget the
Oh,
name
really?
offhand. But yeah, if you look at Micro Center, you'll see it's a resin printer. Actually, looks it does a pretty good job.
Oh, really?
The print in front of me.
Yeah.
But
is it too big of a headache though? Because I remember with that.
well, they have washable. You can get the washable resin, and it's
Oh, okay.
$30 for I want to say Torp. I forget exactly, but yeah, if you could Google the Micro Center and look there, I would recommend that one. It's
Okay.
pretty straightforward. It's easy to use,
Yeah.
and you don't have to deal with shipping because it's at Micro Center.
Yeah.
Only thing you have to deal with right now would be the ice and snow, but
Yeah. Oh yeah. Hmm.
I'd wait until next week. Don't
well,
wreck
at
your
least,
Tesla to buy a
Yeah.
$200
Yeah.
printer.
Hmm.
but yeah, the only drawback is its bed size is small. That's the one thing
Yeah.
you'll run into right now, which is why at $200 I was like, okay, I can buy, but I was toying with waiting for later for bigger, but
Hmm.
and eventually they'll get bigger.
Hmm. So I
But
found
for
Well,
the
that,
one that I was thinking
SLA
of getting. Oh.
SLA uses a lot of resin too. I mean, the filaments,
Uh.
the liquid's much more expensive. So if you're printing out large objects, you probably want to rethink that.
Yeah. I'm
right.
actually. I'm trying to print out. I'm working with this organization to try and print out ultrasounds prints
Hmm.
for people that can't afford to buy ultrasound prints for like their babies and stuff. And that's why I was wanting a higher resolution printer.
Oh, it'll give you a very high
Ah,
resolution. It's like
Mhm.
0.001, whatever.
Yeah.
Because it's like, you'll be amazed at the resolution difference.
Hmm.
And well, hopefully, maybe next week I'll have can grab it apart and show the difference
Oh yeah, that'd be
for
cool.
that. But yeah, but
Yeah.
you can go to the website of that company and I forget the name offhand.
Okay.
You can see the specs for that printer, so it's pretty good.
Okay.
And then at the Micro Center, I
Hmm.
mean, at Makerspace, they actually have one of those. Well, a variation of that there.
Ah,
I
okay.
forget their brand, but
Oh yeah, it's a form
there's a
printer, isn't
couple
it?
different brands out there in ours.
Hmm.
So, but yeah, hopefully next week I'll have A picture or B a part I can show you.
Oh, okay. Yeah, that would be
Maybe.
nice.
Are you saying that people are starting to 3D print their fetuses?
Yeah.
No, well, they probably could.
Wow.
Yeah.
I mean, the resolution would be pretty good. I mean, they use the resin printer for uh, they digs and the bones and that, from reptiles and that at museums. So
Yeah.
yeah, I mean the resolution is pretty good
Hmm.
for fossils. Yeah, where they'll
You can
make copies
set
of
up
fossils.
Yeah.
expectations in the womb. You want
What?
little Johnny or Janie to be, a violinist or a physicist or whatever, and say, this is how you started, and this is when your career began.
but but
Are you going to do the
another.
same as the 3D picture people?
What?
And are you going to do the same as the 3D picture people? And have any one of a couple dozen pictures and just send that one out to whoever pays the money?
That would be easier, wouldn't it?
Yeah, you don't have to scan anything. Just print out the same one and ship it.
Yeah, they'll never notice the difference.
Looks like a peanut.
Not
What's
very
the difference?
distinguishable at that point.
Or it could be cool, the little glass crystal ones where they laser dot the inside of the glass.
Oh yeah, that would be cool.
Those would be pretty neat too.
Oh yeah.
There's your business, Jack.
Yeah.
Baby embryo. Yeah.
Hmm.
Yep. Anyway, I don't know if you can see the image there.
Yep, it's
Oh.
showing.
Yeah. This is it's an old snapper mower. It's self-propelled. As far as, and I have one. I inherited it from my father-in-law, and the engine drives this disc here, through a pulley, and then this is basically a rubber wheel that drives this box, which is a differential. And these are the rear wheels of the thing, and they have a larger one. So this is, pretty much this is fairly easy to automate. All I need is a linear actuator to basically move this bracket back and forth. And you know, it'll drive these rear wheels either forward or backwards, depending on where this disc is. This one was limited only to go forward, but if you extend it so it can go over on this side of the disc, it'll actually push it backwards. And they have larger ones of these. Where is it? Yeah, like these. I was just kind of fascinated by this. This is it's a rear engine mower. This was the balance. Most of the weight, you know, is going to be back here, the drive mechanism and the engines on the, you know, back side of the rear wheels. And it puts a lot less weight if this thing is unmanned, to be able to twist this rod, which is, you know, how you steer it. So basically you'd have a servo here and another servo pulling this lever back and forth here, which is the direction and speed. I'd have to stick a clamp on this thing because that's how you engage the lower bar. You know, that's pretty, you know, the safety mechanism is pretty easily defeated. But anyway, so I was looking at those, kind of intrigued by that since I had one. It's kind of a you know, a mechanical means, and as opposed to completely electronic, you know, to be able to push a mower or to automate one. So that's kind of what I've been obsessed about. I'm talking to the guys that are selling them, and they kind of range in price, but some of the parts are interchangeable, and they still sell them. They're fairly expensive. Anyway, let's see if I can get this thing to stop presenting. There we go.
You've stopped.
Anyway, that's
Yep.
what I've been looking at. That, and I found some other linear actuators similar to the one that I've used before, but it actually, the back end of the motor is accessible. So it's kind of like a wiper motor. It's got a worm and worm gear, and but that one, the one that I've used so far, the back of the motor was not accessible. And these other ones that I found on Surplus Center are. So that makes it a little easier to make a linear actuator, because I can stick instead of sticking the encoder on the end of the shaft, I can stick it on the back of the motor. But oh, and well, Pat, you may have already bought motors. You might want to look on Surplus Center if you haven't. For those, they have a fairly long shaft. You don't have to use the lead screw as a linear actuator. You could actually use it. You could actually mount the wheel on it. And they're I think they were used as seat adjustments for like height and, you know, shifting the seat forward. I can go to where it is if hold on a second. And do a share again if you want to see it. Screen. There. Oops.
And these are new items, Ray?
They're surplus items. You can get them at MPJA. Let's see, I've got to select the right one. Okay. this was the one that I've had. I got it at Tanner's a while ago. You can see the back of the motor is not accessible, but it actually comes with the nut, which a lot of them don't. It's $15. I haven't found it that cheap anywhere else. But you could, instead of using this as a, lead screw, you could actually take the nut off and mount a wheel to the lead screw, and then it's more or less like a wiper motor. This has a worm and a worm gear, so it's got a pretty good reduction. The other one actually has the back of the motor. You can access it. There's a little square opening in the shaft, and it's you put a piece of 1/8 bar in it and stick an encoder on the back of just on the back of the motor. They're meant, well, with the lead screw, they're made to lift like several hundred pounds, for like a seat height adjustment, that sort of thing. MPJA, it's another supplier. Marvin P. Jones and Associates actually had, I think, a little bit more accurate information on it. They were saying the extension time is 6 seconds, but it's more like 2 seconds. So it's a lot faster than what they claim. So I think at 12 volts, they were saying this rotates at like 178 revolutions per minute, which isn't bad. And you're probably, I think no load. They're saying 1.5 amps, which is, I think, about right. So you're probably, and it was really meant for intermittent duty, but for most of the platforms that we have, you're not going to be pushing or pulling, 300 pounds of load on this thing. So you should be able to use it, much more than just intermittent duty. And this I think is 7/16 for the shaft. Yeah, 7/16. And a lot of the places sell this for like $20, and they don't have this nut that goes with it, which you can weld onto it. Stick a tube over the lead screw and have it push and pull like if you're going to use it in linear actuator mode. So found that, but like I said, Pat, you were looking for motors a while ago, and that's about the cheapest I think you'll ever see anything you can stick an encoder on with, something you can mount a wheel on. They have the left and right side versions of it. So kind of like, I forget what they call those. They're the things that raise and lower a window, that motor. They have left and right versions of those. So you can see here they have left and right versions of these. These two I wouldn't get because they don't have access to the back of the motor, but I would get these two because they do. So, and
I've looked at those in the past for like a linear actuator or like a giant servo. Something that you can move. I've ordered a couple Pololu motors.
Oh, you did already, yeah.
For my robot, yeah. So I'm hoping they're going to be a little quieter, 37D motors.
Yeah.
And we'll see if they're a little quieter.
Yep.
Anyway, the price was a little better.
Yep. Anybody else is interested in it, go for it. I bought a bunch of stuff from them. They're pretty reputable. So I definitely recommend them.
To get that motor to Canada, that would end up being close to $40 Canadian.
Really? Wow.
Shipping would be more than the cost of the motor.
Yeah, that's what I hate.
So
what makes it so expensive? Is it customs and taxes, or is it literally the shipping cost?
anything coming from the U.S. to Canada is you're paying union labor rates, so it gets quite expensive. Most of it, not all of it, will come United States Postal Service. It'll come by a courier, and that gets expensive. It's amazing. You look at stuff online and you say, hey, you know, a little microprocessor or whatever. Hey, it's $12. Turn around. Oh, I should order that one of those. So then you click on add to cart and you click OK, ship to Canada, and you know your $12 microprocessor has $24 US shipping to Canada. So you really got to watch where you're buying stuff from, just because the shipping kills you. It's
So
funny,
much
you
for
ship
NASA.
something from China for free. It's like the other stuff I ordered. It's on a slow boat and it'll take forever. But you know, it's, I guess, because of the agreements between China and Canada, and probably the same with China and the US, they ship it for dirt cheap, a penny, whatever it is. And Canada Post has to deliver that, or the United States Postal Service has to deliver that as the receiving end of the agreement.
Yeah, our tax dollars help subsidize our purchases that way. So yeah.
Yeah, so that's why a lot of times it's worthwhile to wait 6 weeks for something to come in and order it out of China. Thanks for the link.
Sure.
Thanks, Ray. That's a cool update.
I
Let's
can
see,
go
swinging
next.
around. So, John, what you got?
Some quick update. So last time, it's like 2 weeks ago, Doug P mentioned I was trying to figure out how to drive my robot with a computer, right? So there was the suggestion to use a Wixel, this type of, I don't know if you guys can see this.
Yep.
So, but yeah, so it works really well. I got a pair of this. It's like $20 each, and basically, so I wrote something on the computer to talk to the Arduino via the COM, and it's kind of transparent. I put two Wixels in between, and everything just worked. So yeah, it was a good thing. I do have to shift this 5-volt this RX TX to the 3.3 volt. That Arduino voltage is 5 volt. So yeah, that's something. Right now I put it on the breadboard. I have to solder this. So yeah, there's some work. I need to do some soldering to make it compact. But yeah, at least it's this wireless link is good. So that's my update on my main
You
progress.
can just use two resistors.
Last one. I'm sorry.
You can just use two resistors. You're talking about the RX pin.
That's right.
The
That's right.
Yeah.
Yeah, I use two resistor. Right now I put it on a breadboard. I basically I need to. I mean, one thing is to wire this with the resistors sitting it next to my Arduino board, right? So I think it's a good time I solder this together like on a prototype board. This is one reason. The other reason that my robot, I know some connection is not good. So it's like sometimes one wheel doesn't turn, and I think I was really delaying this, but I think I have to now. It's gonna kind of roam around. I need to make it secure, and yeah, I just can't have it like running on the shoestring anymore.
Yeah.
Yeah.
Hey, maybe you could use the Wixel and a little telemetry to figure out, where it's breaking down. Is it? Can you read the encoder? Can you?
Telemetry. Yeah, that's even more fun remotely debugging this.
Yeah.
Yeah. Yeah, so I think I've been a little concerned about this rewiring, but I ordered a bunch of prototype board, and I think I'm gonna start working on this when it arrives. So yeah, and the power outage is crazy. So earlier I had power out, now I had power. So yeah, so it's
Huh.
anyway, I'm gonna go back to kitchen and work on clean it up before power goes out again.
So you're experiencing rolling blackouts too in California?
No, wait, I'm in
Oh,
Dallas.
you're
I'm
in
in
Dallas,
Dallas.
John?
Right, yeah.
Oh,
So yeah, we're on the same boat.
oh, I thought you
Or you
were.
know, we're on different boat but in the same ocean with a lot of
Oh,
rollings.
I thought you
And
had
he's such a
moved.
dedicated robotist that when he gets his power, he jumps on the call.
What's that?
He's
Yeah.
such a dedicated robotist. When he gets power, he jumps on the call.
Yep. Yeah, that's good. Dedication. Did you move back from California a while ago?
Right, I moved back like 2019. Right, I was there 2 years. You know, my family
Oh,
didn't want to move over there,
I
so
kind of got the impression you were still out there.
yeah, I was
Okay.
in like near Santa Barbara for 2 years. I mean, well, for I went there and then I was like half time there, half time in Dallas, and after a while, you know, it's like, well, it we won't move over, so
Hmm.
it's easier I move back,
I'll be
like
darned.
rather than, you know, going every 2 weeks.
So
And
on your power outage, how many hours have you been out of power?
over here in Coppell, I think it's the pattern is we get power in the afternoon for like less than 3 hours, and then in the evening for about 2 hours, and sometime in the morning it'll come in and last till like 8.
Okay,
So
because somebody
covers
else
like
I was talking to,
breakfast time.
they were effectively having more than 8+ hours, and then maybe 30 minutes of
Yeah,
electricity, and then back to no power. So
yeah,
you're
it's
doing better
really
than they are.
random. I mean, we have people just nearby. There's family. There's people that having less time than us. I think we are not on the low end, although I've got colleagues doesn't have power out yet. So
Oh, yeah.
yeah, maybe they're on a priority circle or something. But yeah,
How are you heating your house without power?
I can't. I was
Oh,
thinking we burn gas, but everything's controlled by electronic. So
Yep.
Takes fan to move the hot air around. So
it's not too bad. I mean, I've got
yeah.
a few friends with broken pipes already. Um,
oh.
Yeah.
yeah, it doesn't take much to to be so cold. The big
Yeah,
house is, I think, is hurting more.
Carl was telling us that you guys have a habit of putting plumbing in outside walls.
Yeah, we've got that problem too.
Like,
Yeah, I think so. I mean, plumbing. Wait, what when you say plumbing, are you talking about
Water.
all the pipes?
yeah.
Yeah. I mean, right. The kitchen is right next to the wall, right? So all the faucets and everything.
Yeah, we are as well, but we put them through the floor. Now, in
Well,
Canada, we try to keep all the plumbing on the inside of our igloo, not on the outside.
yeah. I was
That's thinking
asking,
ahead.
is this just Texas so bad? Like, are we on the worst end of this winter storm, although we are on the south end?
I can tell you this: it's minus 20 Celsius tonight here, and it's been like that for a week. Daytime highs around minus 10, nighttime around minus 20. Don't go out. You wear a t-shirt.
Yeah.
My furnace is working.
Put the socks on your sandals.
Exactly.
Here in Iowa,
Yeah.
it's minus 20 Celsius right now as well.
Yeah, it's part of that polar vortex that's coming. It's
Yeah.
coming way down.
Yeah.
That's usually about the worst of our winter here, where we are is -20, -24.
But
Yeah,
I think what
Texas, too little preparation.
well, that's what it is, right? That Texas
Yeah.
has its own little power grid, and it wasn't prepared for this.
No, well, I was watching a video with the power lines burning up with the ice coating on them and stuff like that. That's, you know what? Up here, when we get freezing rain, it's hard on power lines.
Yeah.
None of it is engineered to last that long. In Quebec, they have 500,000 million-volt power lines coming from northern Quebec down to southern Quebec. And they'll actually play with the voltage at both ends so that they'll induce heat on the lines. Melt the ice.
Wow.
So they'll increase the voltage drop essentially on the lines and basically melt all the ice off of those million-volt lines.
That's funny. Just enough
Well,
to
what-
heat them, not enough to fuse them.
What's
See you,
a
Donna.
few hundred watts, or even a few thousand watts of loss? When you're probably transmitting, who knows what megawatts, I guess.
Hopefully,
So-
Quebec sells megawatts of power into New York.
Say it again. Say it again, Pat.
Quebec in Canada, they sell thousands of megawatts into the U.S. into
Oh,
New
they
York
do?
State and stuff.
Hmm.
So, two of our
What's the
provinces
ultimate
that have a
score?
lot of electricity is both ends of the country. So Quebec in the east side and British Columbia in the west side, and they both export power.
This
Into the US.
hydropower?
Hydro, yeah.
Really?
Okay.
Wow.
There's some big
Yeah.
rivers. I heard.
There's both of them have big rivers. So Quebec has some mountains, and they got runoff in the mountains and stuff like that. Lakes, all sorts of rivers, and then BC, it's all snow runoff from the mountains.
Wow.
Cool. I heard a friend in Quebec said when the skiing location is like they can see a river as wide as the ocean. That's kind of what I heard, but I can't really imagine what it looks like.
No, I haven't seen any rivers as wide as an ocean. Well, the St. Lawrence Seaway at the mouth where it goes out to the ocean, it's pretty wide. You can't see the other shore.
Yeah.
So Trump had an issue with aluminum. Canada was dumping aluminum on the U.S. markets. Well, the reason Canada is able to sell aluminum very cheaply is because the two places we make aluminum is Quebec and BC, because electricity is dirt cheap. There's so much of it.
Yeah.
Yeah, makes sense.
Same thing in Iceland. They there was on the East Coast. They actually had a aluminum smelting plant, and it's because they had it was like glacier melt and kind of a constant source of well, actually that one might have been geothermal.
Yeah,
But-
because a lot of those Finlandic countries are using geothermal heat, and they're spinning up turbines and generating tons of electricity.
Yeah. I think that one was geothermal. But I guess great place to smelt aluminum.
Well, that's exactly it. It's the reason it's cost effective.
Yep. Huh. Didn't realize that.
Well, that's kind of my quick update. So I'll pass the baton to, I'll
right.
pass the relay to someone else now. Thanks.
I think we've pretty much gone around the table. Is anyone left that has some stuff to share? Nope. Just going to go back to our igloos and fire up the fireplace. Pat, I did invite you to the one GitHub repo, so check your email. And if you have any questions, just email me. I'll help you through it.
Okay, yeah, I see an invite there, so I'll follow through on that.
Yep. But other than that,
I'll grab the code and then you can uninvite me if you want.
yeah, no worries. Hang in there. Just I don't think you can trash it, but if it's of any value to you, see what you think.
Anybody's code is of value to me.
Well, be careful as you say when you inspect mine. But all right.
Hey, Chris, you were kind of implying I had used a Raspberry Pi on my ROMI platform. I never have, so I've kind of just used the OpenMV H7, and so that platform's never had a Raspberry Pi on it. So you're much further along, and you've explored many more options than I have with it. So
Yeah, I mean, that's what I liked about the Romy platform. And I mean, you can do a lot without the Pi, but
Yep.
you know, that's the sort of thing, right? You want the Pi for, get the camera going, get the video stream going, and it's hard to do with probably with the OpenMV. You know, you don't have that same flexibility. It's much more turnkey, but don't
yeah,
have the flexibility. So yeah, I'm really liking the Romy platform, and I have 3 decks now. I haven't been using my LiDAR much lately, but you know,
wow.
I don't think I can go much taller than that. But
All over.
yeah.
Yeah, actually the connection to the OpenMV H7 is simple. It's you know, just to transmit like a serial. I'm using serial, and you know, it doesn't receive anything from the Romy platform. I'm just transmitting, you know, like an X value for steering. So it's very simple
Yeah.
to connect to it. That's
The one shortcoming of the Romy
3 wires right there.
is that it doesn't have a lot of I/O.
Yeah.
It's a shame. I mean, but so one thing I've done recently, I don't know if I showed it last time, but I've put on this middle deck on, you know, an Arduino Mega,
Yeah.
and you know, pick your favorite microcontroller. But I had this one, and the reason I used this one because it, you know, the libraries for the B&O 085, they just work out of the box, you know, boom, 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 don't have to think much.
Yep.
And so I've been thinking a lot about how to interface something like the Mega, and it's a topic we've talked about before, right? And may have mentioned that, but I'm just using the USB coming out of the Mega to go into the Pi, and I've had to do this on a couple of occasions now, even with the LiDAR. I had to butcher my USB cables, right? Because if I want to be able to remove the deck, I gotta be able to disconnect, and
Yeah.
you know, so I find myself buying all kinds of right angle USB cables, and then I butcher them, I cut them, and then, you know, reconnect them. But as you can see, I go in between decks here, you know, back down to the lower deck into the USB ports on the Pi, so
Yeah.
I can remove the deck. It doesn't take me too long, you know. A couple of things I have to disconnect, and then I can disassemble the deck. So it's, yeah, it's a neat little platform.
Yep.
An extra inch of space would have been nice in diameter, maybe, you know, but I kind of bought it for the form factor in a sense. It's kind of, you know, small, compact, big enough to put stuff on.
Yep.
Looking
And,
forward to you coming back next week with the second part of your AWS project.
Yeah, so I'll fiddle around with that
You
stuff
can-
a little more, and then we need to get back to some of my other things with the LiDAR. Still wanna, you know,
So
I still wanna.
I was gonna say, in comparison to mine, yours is definitely decked out. I only have half a deck, you know.
Hey, on the Tele API thing, I meant to I should have brought this up when Donna was still here, but she had suggested that we have a kind of outside of this meeting, outside of the Tuesday night discussion on the spec or whatever. And I think Doug and Chris, you're the two on here that are in that thread, right? Would you guys be open to something like that, like maybe a Thursday night 1 hour or something, just to focus on that API by itself?
I'm okay with that as long as it's not second Thursday. I have something else then.
Mm.
The real question is, with Chris making so much progress on what he's done, what's going to be left?
Well,
There's always something else.
it's superficial progress. It's superficial progress.
Well, from my view, Chris, you've got a bunch of really valuable empirical constraints, right? They show us guidelines that we can think about in terms of what we should design to, right? So we know that certain things will work well for real-time driving and certain things probably won't. But I think still, like Doug, like I find it interesting when I compare the document that you have, which seems to be kind of low-level, detailed command oriented, and then the one that I've got, which is more like, what the hell do we really want this thing to do? And I think, to me, there's a lot of space in there that still needs that we ought to think through before we start to pick implementations. So it seems to me like if the design space is way out here, that if we're going to compile this thing to something that's usable, it's going to take a bunch of iteration. I mean, both at the abstract level and then at the detailed grubby level. So that's anyhow my thoughts on this.
I lost
So-
connection there during your presentation, Chris. Do you think for the speed that you have to move or would like to move, that I think you said you had a delay of like 150 milliseconds. Do you think you could, pan and tilt and move the platform enough or fast enough with that kind of delay?
I mean, there's going to be a speed limit for sure. I mean, I
Yeah.
certainly when I'm on my phone with that Romy control panel, looking at the robot, driving it, I mean, I can drive it pretty fast without crashing into stuff, so
Yeah.
I had to slow it way down. In fact, I had to change the polar loop code so that it doesn't even let me go as fast as possible, just because you can get yourself into trouble real quick, right? With that delay. So for sure, you cannot, and I don't know what the speed would be. I mean, the Romy can go almost 3 feet a second on fully charged batteries. I don't know how fast I can go safely, with 0.2 seconds of latency. I don't know, but again, for the kind of use case we have in mind, telepresence,
sounds fast enough.
One foot a second is plenty, I'm thinking, right?
Yeah.
If I had to pick a number, I would say 1 foot a second is plenty.
Not unless you're going for the Ferrari version or something, that you really want.
Oh, we've seen how you did a line following course, Chris. So
And one thing I came to realize, there's a lot also depends on the user interface of the remote control, right? I mean, so that little touch screen rectangular area that came with the Pololu libraries, it's a very finicky thing, right? Because you're kind of controlling speed and turn rate
direction,
at the same time. And if I just want to go straight ahead, you can't really find the exact right spot on the touch screen to just go straight. It's actually not a convenient user interface. It's very easy to sort of drive off at some arc when you actually want to go straight. So like I said, much is going to depend how fast you can go on the user interface, because I'm thinking what I really wanted from the interface, I would want a way to say, go forward at some specific speed, just go straight, and then I just focus with my fingers on the turning, right? And unless I tell it otherwise, just maintain your speed, and I just turn. I don't want to have to control forward speed and turn rate at the same time. It gets too difficult to control, right? That's one thing. The other thing I was thinking for a user interface, again, I may have mentioned last time, my drone reminded me of that, right? So that the notion in the mechano wheel robot of going sideways, I would want a user interface where I can tell it to go straight, and it does its thing. And then I push a button or whatever, turns a knob, the touch screen or what have you, and it does one of these, it goes sideways. Well, I wanted to turn, avoid an obstacle, and then go back towards the original heading, right? Whatever my heading is, let's call it, 100 degrees, avoid the obstacle, maybe under my interactive command, but then go back to 100 degrees. So I have never seen, any of these gadgets and apps and whatnot expose that kind of user interface, but I think I would find it convenient to use because a lot of times, right, you just want to go into a general direction, but sometimes you have to avoid something. But for me, to manually control the angle so that I'm again lined up with my original heading is kind of hard. You end up turning and then you turn back too hard, right? And then you're going off at some angle. So I think the user interface for interactive telepresence, especially given the latencies, play an important role.
I
Do
agree.
you think one slider for forward speed, another for left and right would work better?
Maybe I think I would need to play with it, but I think that would work better because you leave that one slider, for forward speed at a modest speed,
Right.
and then you just focus your attention on the turning.
Left to right. Yeah.
But I would think of it two different ways. So like I did just that when I did the layout of this for my the hovercraft, the Mechanic Wheel one. So like this just does translation left to right or forward to backward. So for a differential, it would only do forward to backward. And then this one is just left to right. But then I also have it so that if you only want to move in one dimension, like this only does translate one way, translate the other way, like go backwards, go forwards, turn left, turn right. So with a layout, you can very clearly separate, and I can mix them up. I can say turn at a constant rate, a low constant rate, and then translate with the joystick however I want to. And that's been fun to play with. But I think so. That's one level. I think just by having a smarter way to decouple and orthogonalize the UI, I think you can do a lot with that. But I really like, Chris, where you were aiming with the let's get some intelligence. After all, we have these autonomous things that we do for fun, right? So why don't we have the command that make a button be a jog left and go straight button? So go left and straight. But I think what would be really cool if we could extend that, like especially if you do a first person view of the robot onto a web page, then you make the map of the web page clickable. Then you could say, okay, aim here, move the robot here and point it at that subject. And if you tap on the places in the image, then all the magic happens and the robot says, okay, I don't care that there's a chair in the way. I'll drive myself over there and then I'll turn to aim at that subject.
Yeah, I mean, I agree. I mean, the real-time interactive control, I mean, it's a nice to have. I'm not sure it's gonna be 100% feasible and under all conditions.
It is. So I'm on this UI, if you guys remember. I'd say basically you have the modeling to support this kind of motion and how to present it. I think we can figure this out. So this is maybe the part of a prototype effort. But yeah, I'm all for it. I guess I can program on a Windows system with some UI to try it out, or maybe a web. I mean, if it's through web. But yeah, this is part of this UI which I can work with. I mean, I can contribute to. So yeah, thanks for the suggestion, Chris. Great idea. And clicking on the somewhere, yeah, we can convert that into a trajectory. Like you click on a map and figure out what is the S shape to go there and command to this model to drive. And by the way, the Thursday evening I'm fine to join.
Oh, good.
The meeting.
Yeah, I'm glad. Thanks for speaking up. I see your family face there, so I keep forgetting it's you because it's like a chorus of people.
Oh, the funny story. The first thing I did was I was uploading my chorus video to the YouTube, and somehow it gave me an icon like that. I've never really chose that icon, but Yeah, I don't know how to. Well, maybe I'll look into changing that. But
That's all
it's
right.
been there since I've first seen the Google account. Yeah,
It's
so that's
funny.
me. Yeah. All right, I'll go back to my dishwashing.
Oh boy, no worries. Okay, guys. So it's what we've been I don't even know, 3 hours or so like usual. So no, 2 hours. 2 a little shorter tonight. Okay. Hey, well, if there's nothing else, I can't join. Like, if we wanted to do a Tuesday night call this week or Thursday night call this week on the API, I can't do it. But Doug and Jean and Chris, if you want to, go right ahead. I can do next week, though. I'm sure of it, most likely. So,
So
I'm
you're,
free the 4th, but I'm not free this coming Thursday.
you mean 2 days from now?
Right. I'm
Okay.
free then. I'm not free on the
So let's
20th.
see next week how things go.
Yeah,
All
next
right.
week sounds
That'd
good.
probably be better.
That
so
sounds good.
Carl, you're gonna brave it and
Friday
rely
morning.
on the wrap to get you home this couple days or what?
Friday morning, I think I'll be able to have a clear shot.
That's the window, huh?
I got like a
Go to
day
Mars.
a day and a half of departure time for a clear shot.
So are you going to drive, or are you going to stop in midway somewhere for sleep?
I'll sleep in Nashville.
Okay.
You got chains or something that you can throw on your tires if needed.
No, just macho luck on a lightly loaded truck. Yeah.
Without snow tires, no less.
That's
right?
true.
No, they're new tires, but it looks like there'll be a little bit of snow in western
Do
PA
you
and into Ohio, but then it'll clear up.
Do you get snow tires?
No.
Because
They're-
tires are better than a couple years back, but
They're just new tires with deep treads.
okay.
Unlike July, when I got home and I realized that I could see the metal
Yeah, that's not
the
good.
liner inside the tire. That's
The bands, yeah.
the bands. That's the bands. I
Yes,
found those
yeah.
when I got
I had one winter with tires like that. I couldn't even get up a slope that was like this. I
Well, at least you don't have a small truck. I remember I had
Yeah.
a Dodge Ram D50
Yeah.
import one, and it was super light. And it was, did not do well on ice.
Maybe I'll load the back down with Yingling beer or something. We'll see.
There you go.
It was a good idea.
I've had several vehicles with studded winter tires.
Yeah.
Yeah.
Well, they're
yeah, we
illegal
said-
in a lot of places here.
Well, in Quebec, they're mandatory from, I think it's November 1st till March 1st. They're mandatory.
Mandatory and
And
they're illegal
yeah,
here.
in Germany, snow tires are mandatory.
Yeah. So when
At
they
least
first
your
brought
insurance
out-
company insists. I mean, I don't know if it's legally necessary, but your insurance is gonna insist.
yeah.
Pat,
The other one, I
what
think,
was the name?
all weather tires as opposed to winter tires, and they did a little better in the snow.
Pat, did you
Yeah,
say
Carl, you're
studded
talking about
tire?
Studded, yeah.
Studded. Huh.
Little metal
Made
studs.
Yeah,
little metal
look it up.
Oh.
Little metal studs in them.
Like
Yeah.
soccer boots,
I see.
I bet definitely, yeah. Are they
like
removable?
running shoes.
I don't think they make removable versions.
The studs?
I actually
Yeah.
don't mind it.
Yeah, they do. 'Cause they go in from the outside. They actually got a tool that there's-
Okay,
if you
that's
look
what I
at
was
the tire,
thinking.
There's always a little hole, and it expands that hole and sticks the stud in.
I was thinking you can remove them. So yeah.
So
Yeah,
it's-
Carl, my first car, I had tires like yours in the winter, and there's a bridge over the Mohawk River, highway, I think it's Highway 87, and the car just started like fishtailing before I got to the bridge, and then once I hit the bridge, I did a 180. So I was facing 3 lanes of traffic early in the morning trying to get to work, and it's kind of like, that bridge is very, very high up off the river, by the way. So, you know, I was like, I'm going over the edge of the bridge.
I'll have some bridges like that, but we'll see.
Yeah.
Well,
Shortly
hopefully,
after that, I got new tires.
so hopefully we'll see you Tuesday even.
In one piece, without a big bandage on my
One
head.
piece.
That's right.
Yes.
Okay. In the
Okay,
meantime,
guys.
see
Take
you,
care.
Carl.
Good night. Good night.
Be safe.
Nice.
Stay warm. Bye.